Black holes might simply be one of the most captivating and mysterious phenomena in the universe. They're huge beasts in phrases of energy, but at the same time actually invisible to us, like a black hole weighing possibly 2 to 4 million times the mass of the Sun. Due to the research that was positioned into them over the last couple of decades, we've gone from understanding truly nothing approximately them to getting to research increasingly more up close and personal. Even as things have just gotten crazier, Kaku simply announced that we eventually were given to have a look at what is interior a black hole. This new records brings light to the details the arena of technological know-how would possibly have missed all along. Be a part of us as we dig deeper into black holes and unveil what's inside. Area is massive. Terrible. Before we get into the details of what Kaku found, we have to talk approximately the first. Despite the fact that most of us have a few idea what black holes are, there's still some gaps inside the right information. You see, in 1916, Albert Einstein published his concept of preferred relativity, which predicted the lifestyles of black holes. At that time, the concept of black holes became in basic terms theoretical. It took any other 50 years for the clinical community to find evidence that black holes in reality exist. This took place in the 60s. They were studying the Cygnus constellation once they observed an oddly shiny blue big name that became emitting X-rays. This famous person wasn't a stagnant item but changed into going around a large black something. Upon similarly research, it changed into observed that the X-rays weren't simply moving around on their very own, but they were being sucked into the black factor they were orbiting. Consequently, the call black hollow. This discovery became enormous because it provided evidence that black holes honestly exist and that they were now not only a figment of Albert Einstein's wild creativeness. Whilst that changed into exquisite, it also meant that there became this unreal entity in space that we urgently had to know more about. So researchers all over the international got to work. This black hollow became named Cygnus X1, and it's far positioned within the constellation Cygnus, approximately 6,000 light-years from Earth. It became no small discovery. It's approximately 14 instances brighter than the Sun and exceedingly dense, which reasons it to have a robust gravitational pull. The gravitational pull is so robust that now not even light can break out. It is referred to as a black hollow. The concept of a black hole is each captivating and terrifying. It's miles a location of space wherein gravity is so sturdy that not anything, not even light, can escape. Something that receives too near a black hollow could be pulled into it, never to be seen again. However, that component of threat makes it even more vital to learn the entirety there may be to understand about them. Was this it, or have been we just starting? The answer ended up being the latter. After the discovery of Cygnus X1, scientists started to search for different black holes. They observed that there can be close to over 100 million black holes inside the Milky Manner by myself. However, because they're so tremendously difficult to discover, we still do not have an actual wide variety. Though from the seams of it, there are numerous several million black holes within the Milky Way and our very own galaxy. That is what makes them even more important to study. So, allows ruin it down. The main issue with black holes is always going to be gravity. Their gravitational pull is so excessive that whatever that enters it compresses down astronomically till it will become a singularity. In simpler terms, black holes are like cosmic vacuum cleaners that suck the whole lot in. One of the scariest components about the studies it really has gone into black holes is the truth that if a person have been to fall into one, they might get stretched to the point that they end up an unmarried line. This manner would happen slowly, and the individual could die earlier than the final shape truly sets in. So let's just say that nobody need to be entering into one. However, they may be all over. So ought we truly be in danger? Despite the fact that the closest black hollow to Earth is 500 to 1,000 light-years away, it is still near sufficient to deliver up questions and worries. In 2021, scientists were capable of launch the first clear image of a black hollow, particularly the M87 black hole. This black hollow turned into photographed several nights in a row, and with every photo, the researchers amassed an increasing number of evidence about it. They needed to stitch the person photographs together to create something that crammed all the gaps. This way, they were able to figure out that there are 3 layers to a black hollow. It's no longer just one unmarried gaping hollow of nothingness, as many humans consider. Matters are a lot more complex than that. To even get to the nothingness component of a black hole, you have to make it through the first two layers. The first layer is known as the event horizon, which is the factor of no return. After you pass the event horizon, there may be no turning again, and you will be sucked into the black hole. The simplest receives worse from there on out. The second layer is the photon sphere, which is the region in which mild orbits the black hole. Any mild that enters this area might be trapped and will not be capable of escape the black hole's gravitational pull. In the end, we come to the third layer, that is the singularity. That is wherein the whole thing that enters the black hole gets compressed down astronomically until it becomes a singularity. The singularity is a factor in spacetime wherein the laws of physics as we recognize them spoil down, and we just cannot expect what happens next. On the singularity, the density is countless, and the laws of physics as we recognize them give up to exist. Now, what makes all of this infinitely worse is the reality that every single black hole you examine may be absolutely one of a kind from the last. Certain, they do have a tendency to follow the same three-layer idea, but the manner they feature might be massively special. Now, if this were anything else, all we need to do is hop lower back on the one's telescopes and just have a look at the hassle handy in detail. But with black holes, you cannot genuinely do that. Scientists can handiest have a look at black holes indirectly by gazing the radiation they emit and the gas and dirt that surrounds them. Sending a probe like the Voyager inside a black hole isn't always feasible because anything that enters the event horizon is pulled towards the singularity, where its miles compress to an infinitely small point. So you cannot waste billions of greenbacks just to get a glimpse, because the second the probe receives close enough, it will simply weigh down into nothingness. Because of that obvious problem, scientists are left without an alternative but to observe these gadgets in a two-dimensional way, despite the fact that they're three-dimensional phenomena. In reality, to make topics even more hard, there also are the two problems of each black hole being specific and the legal guidelines of physics as we know them breaking down whilst we try to discover the internal. This way that the conventional techniques of clinical inquiry do not without a doubt practice to the observe of black holes. That doesn't mean that the researchers haven't been busy. There are lots of different theories and causes of black holes, and with each one, things get greater and greater interesting. One of the maximum compelling theories approximately the formation of black holes is that they're created from collapsing stars. When a celebrity exhausts all of its fuel, it may no longer produce sufficient electricity to counteract the force of gravity that is continuously pulling inward. As a result, the celebrity begins to fall apart in on itself, becoming smaller and denser. If the famous person is massive enough, this method can maintain till it will become a singularity. To recognize the nature of black holes intensive, NASA scientists grew to become their interest to the core of the galaxy M87. Astronomers observed an extraordinary powerful whirlpool of excellent warm hydrogen gasoline that becomes spinning at an aston in phi of 1.2 million miles per hour. The sheer pressure of the spinning disk of gas should have prompted it to violently fly aside in all instructions, but it didn't. Scientists deduced that there had to be a giant mass focused on the middle of the galaxy to save you this from happening. This large item weighed as much as 2 to a few billion suns and could simplest be a black hole. However, it's not the only theory. Where black holes spin, in 1963 the New Zealand mathematician Royer used Einstein's equations of gravity to offer the quality description of a spinning black hole. They confirmed that a spinning black hole would not disintegrate into a point as formerly notion, but into a hoop of hearth or a skinny disk. The disk would be spinning so hastily that centrifugal forces would maintain it from collapsing. This spinning disk of count is called the ergosphere, and it's far the location surrounding the black hole wherein the laws of physics begin to break down. However, the maximum fascinating function of Royer's answer became that it anticipated the lifestyles of an Einstein-Rosen bridge, additionally called a wormhole. This theoretical passage through spacetime could connect two separate regions of the universe or maybe two parallel universes. The idea is that if one have been to fall into a black hole in preference to being beaten to oblivion, one might be sucked down a tunnel through the hoop of hearth and shot out a white hole in a parallel universe. To apprehend how this works, we want to have a look at the idea of spacetime in Einstein's idea. Spacetime is the fabric of the universe wherein items with mass warp this cloth, growing a gravitational field that causes different objects to transport towards them. Now imagine a sheet of paper representing spacetime. In case you region 2 points on the paper and draw a line among them, That is an illustration of how items circulate through spacetime. However, what if you may fold the paper in one half and create a shortcut between the 2 points? That is the fundamental concept in the back of a wormhole, a shortcut through spacetime that connects 2 distant points in an immediately. Wormholes are not only a sci-fi idea, they're virtually a prediction of widespread relativity. Even though nobody has ever located one directly, the purpose is that wormholes are inherently unstable and might fall apart nearly right away. However, the existence of an Einstein-Rosen bridge might imply that black holes aren't simply cosmic vacuum cleaners, however may also be portals to other regions of spacetime. So could we use a wormhole to travel through area and time? Unfortunately, the answer is probably no. Not yet. Even though we may want to stabilize a wormhole, it's not going that we ought to use it to tour faster than light. Einstein's concept of unique relativity predicts that the speed of light is an absolute limit on how fast whatever can tour through spacetime. However, even then, the idea of wormholes and black holes as pathways to other components of the universe or even to exclusive instances has been a topic of fascination and hypothesis among physicists for decades. The concept that there might be shortcuts via the fabric of spacetime permitting travel over exceptional distances or maybe into the beyond could probably be innovative if we may want to obtain it. One of the maximum exciting concepts on this area of look at is the sea wormhole, named after the mathematician Royer who first described it using Einstein's equations of gravity. This form of wormhole is essentially a hypothetical tunnel through spacetime that would connect remote points together with 2 distinctive universes or even one-of-a-kind times within the same universe. The sea wormhole is frequently visualized as a hoop-formed portal, much like the looking glass within the story of Alice in Wonderland. Strolling through the looking glass transported Alice to a world where animals spoke in riddles and good judgment didn't always observe. In the equal manner, passing through the sea ring ought to probably shipping a tourist to any other universe or another time where the legal guidelines of physics might be very exclusive from those we are acquainted with. But at the destination, that might simply be normal. Even as the concept of wormholes as a way of interstellar tour or time tour is genuinely exciting, as we have glossed over earlier, it is also a topic of controversy and debate among physicists. Some have mentioned that wormholes, specifically sea wormholes, is probably unstable or impossible to traverse because of the extreme radiation and subatomic forces surrounding their front. Critics argue that Einstein's equations of gravity, which might be used to explain wormholes and black holes, only work for gravity and not the quantum forces that govern radiation and subatomic debris. In order to, in reality, understand the character of these phenomena, a new concept is wanted to unite the legal guidelines of gravity with a quantum idea of radiation. Throughout the world of technology, this is called a theory of everything, an unmarried concept that may unite both Einstein's concept of gravity and quantum theory. Michio Kaku, who is a renowned theoretical physicist, has been working on a theory of the whole lot for decades. Even though there are lots of different versions of what this will be, the simplest one which has proven promise is superstring theory. Superstring theory unites gravity with the idea of radiation. The concept proposes that subatomic particles are clearly tiny vibrating strings, and that the universe is a symphony of those strings. Just as exceptional musical notes correspond to one-of-a-kind vibrations of a violin string, exceptional particles in nature correspond to one-of-a-kind vibrations of an exquisite string. One of the captivating matters approximately exceptional string theory is that as a string moves in time, it warps the fabric of space around it, producing black holes, wormholes, and different amazing solutions of Einstein's equations. Because of this, superstring theory not best unites Einstein's theory of gravity with quantum theory, however additionally explains many of the mysterious phenomena that we observe within the universe. However, there's something about this concept that clearly throws a wrench into how simple it'd have sounded at the beginning, but in a manner makes more sense too. Exceptional string theory calls for 10 dimensions of spacetime in which the strings can vibrate. That is quite specific from the 3 dimensions of space and 1 measurement of time that we experience in our everyday lives. It's tough to imagine what those greater dimensions might be like, but physicists have developed some conceptual fashions that could help us apprehend. Remember a-dimensional pond inhabited by fish which are only aware of the scale of duration and width. To these fish, there may be no such factor as height, and they can't even consider what it might be like to stay in a 3-dimensional world.